Today we're going to be estimating derivatives from a graph or from a table. It just gives you a ballpark figure on what it is. So in this first example, here's this point, and they want to know the slope of that tangent line. So you just draw one. And I said, well, it crosses at this point, and it looks like it crosses here, so it's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So it went up 4 and over 6. So to me, that looks like the slope at x1. And you can clean it up to 2 over 3 if you want. I did the same thing with this graph. So it looks like it goes through here, and you go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So it was up up 3 and over 7. That's the slope at x2. They just want a ballpark figure. It's something close. Oh, and this one should be negative, right? It's leaning backwards. Okay. So this is notes. All right, using a table. They want you to estimate the value of f prime at 6 using 3 different ways. Well, remember, to find slope, you need 2 points. You have y2 minus y1 over x2 minus x1. So the first time I'm going to do it, I'm going to use these 2 points. I do 3 minus 2.5 over 6 minus 5.99, and that's obviously 50. I used my calculator. Come on, folks. Or I can use these two, and I do 3.1 minus 3 over 6.05 minus 6, and I get 2 for an answer. Or I can use these two. I can use one on each side of it, and I get 3.1 minus 2.5 over 6.05 minus 5.99. Make sure you have your y's over your x's. And I got 10. So I got a 50, I got a 2, I got a 10. Do you think that the function's differentiable at 6? My answer is no. Okay, I came in from the left side, I came in from the right side, and they don't approach the same number. Okay, so it's sort of a case of the left doesn't equal the right. All right, they want you to do the same thing with 10. So I'm going to use these two. 7 minus 6.98 over 10 minus 9.9, and I got 0.2. I'm going to use these two. 7.001 minus 7 over 10.01 minus 10, and I got 0.1. And then I'm going to use these two, and I got 7.001 minus 6.98 over 10.01 minus 9.9, and it gave me 0.191. I got a 0.2, a 0.1, a 0.19. I'm going to say yes. They look pretty much the same, close to each other. Okay? That's what it asked when they want 3 different computations. I did left side, this side, and then the whole overlap. Okay? All right, this chart's talking about position and time. Position. If you do slope, you get miles per minute. Okay? And then they talk about average rate of change, which is average rate of change, AROC. I never called AROC, but my teachers I work with do. So that's where that AROC comes from, average rate of change. It says, what's the average rate of change for the airplane from t equals 0 to t equals 6? Here's 0, here's 6. You're just doing slope. 6 minus 0, and I got 2.002 miles per minute. Don't forget your units, okay? AP exam, free response questions are worth 9 points. You leave off the units, that's 1 point. You did all that calculus right, don't lose a point for units, okay? Then it says approximate the instantaneous rate of change for 3 in 3 different ways. So here we go again. 5.125 minus 3.171 over 3 minus 2 is 1.954. I did 7.312 minus 5.125 over 4 minus 3, which is 2.187. And then I did these and have 7.312 minus 3.171 over 4 minus 2, and I got 2.07. Remember, these are all miles per minute. Miles per minute. Miles per minute. Okay, they're all pretty close to 2, so that's what I would estimate. Okay, that's all there is for this lesson. Make sure you go and watch the next video talking about the power rule. You'll like it.